Hi, this is Stuart, and today we're going to talk about the 7 pillars of enterprise architecture, or rather re-talk about it, as a methodology for thinking about enterprise architecture in general. One of the things that's hard to do when you're thinking about enterprise architecture, so it's anything that runs in a big data center in the cloud, that has lots of moving parts and components, that may have platform as a service or software as a service components, is trying to find a way to dispassionately compare alternatives. And the other thing is that I think it forces good decomposition by forcing folks to think about capabilities instead of the minutia of implementation, which I think is a way of stopping yourself from diving into too early, right? So going from a set of requirements to a set of abilities to a set of pillars, and then for each of the pillars saying, well, what is available in my environment that satisfy those? And so it's a good bridge from your high-level domain-driven design to sort of the next level of architecture, the beginning of an implementation without having to be overly specific about the implementation, which allows you to focus on non-functionals and constraints and so on. So here's version 2 of the 7 pillars. And this evolved as part of a lot of back and forth between my peers and I about how to think about that next layer of architecture and how it informs design, and how some things ought to be separate and some things ought to be lumped together. Lumping and splitting, is the primary thought problem behind a lot of architecture. And so after a lot of consideration, we came up with these new pillars. Many are still the same, but others are different, and in any case, we're going to walk through them all. So infrastructure is the base of the pyramid. It supports everything else, on which we have compute, storage, datagrams, messaging, transformation, and other. And as it transpires, you can think of building specific implementations by combining different parts or pillars together. And obviously this is just a bit of an artificial example, but it's a way of showing how at the right level of granularity and abstraction, you can think about things, and those things can lead to concrete implementations. So the infrastructure pillar is the triad of networking, storage, and compute. And in the compute triad, we always think about CPU and RAM together. They're sort of, there's no point in having a CPU without memory, and there's very little point in having memory without a CPU. And so we always think about networking and storage as being separate from those two sort of twinned ideas of compute, GPUs, CPUs, whatever, and RAM together. The modern infrastructure, whether it is programmable logic arrays or whether or not it is slot computing where we have big racks of RAM and CPUs and GPUs and fiber cards for storage and fiber cards for networking and so on. A lot of these things are not what we think about when we think about infrastructure in the old school. And by that I mean kind of 10 years ago, where there's these distinct boxes with clean edges. From point of view of a developer, you have those 3 pieces of the triad together. And, on top of that, they do stuff. Infrastructure in the enterprise space is always accompanied by this very critical and necessary assumption that we're going to treat the infrastructure as code, and we're going to use tools like Pulumi or Puppet or Chef or Ansible to allow this to be true. and we're going to consider the abilities, especially security and agility and things like that, as part of our build out of infrastructure. We're going to be asking the questions using the ability matrix and saying, is this going to satisfy that requirement? So compute is essentially anything that hosts the code that we normally write. Most of us who are developers, we write code to compute things. And so, VMs, containers, headless computing, serverless computing, any manner of compute host, these things are all part of the compute infrastructure, and each variation has its pros and cons and its use cases. And I say use cases because that's probably the most important way to think about where our compute is going to go. Right? We know we need to be able to compute the value of a commodity or something, and we have so many choices now about where to put that we should then go back to our abilities and think about, the trade-offs that each of the flavors gives us. And affordability is kind of that 11th ability. And so, these things do have pretty strong, in many cases, cost trade-offs that are worth thinking about. But the thing that's important to, I think, focus on is, especially thinking at this level, that we want to really think about compute as the place that is our 80 to 90% code hosting and execution. So then there's this idea of storage as a pillar. And storage as a pillar can be, file systems, blobs, tables, queues, streams. Although in many cases, queues and streams belong to a different pillar. It just depends on their implementation. They all have different abilities and capabilities that, again, you want to think about abstractly, and you want to put desired capabilities ranked and try to put some strong non-functional requirements with actual testable goals against those. And at the end of the day, what we want to say is, after we've done that, is, okay, which of the alternatives fulfills our requirements deliberately? For example, if we know we have an archival system and we know that we have a compliance recommendation, one of our attributes that is testable is whether or not it's a write-only read-many system, because that's a requirement. That indelibility is a requirement that comes with certain use cases. And again, it's all about the use case. Datagrams as a pillar is a new and interesting idea. But this idea that we can make a high level, at the domain model, we can make a high level set of messages and entities and other kinds of datagrams, and that they have a life of their own, separate from what computes on them or transforms them or whatever. And by thinking about datagrams as opposed to, I'm going to need a table in a SQL server, or I want to use Mongo as my document database or whatever, it forces us to think about those datagrams and how they're going to be handled and how they're related to each other, if they are at all, in a more abstract way than just jumping to, the shop standard is food. And so datagrams have been elevated to being a pillar of their own, because they're worth thinking about separately from the other things, or as an accidental afterthought of compute or one of the other pillars. So messaging is less about the datagrams. The messages in messaging belong to the datagram pillar. But the way that messages flow belongs to the messaging pillar. And so we look at the kinds of abilities that are desirable in messaging systems or queued systems or caching systems. And again, we think about use cases, right? This approach is designed to make us think about use cases and then say, all right, well, what specific implementations are the best fit for my use case? And then transformation. So transformation is interesting because transformation is defined as anything that acts on a datagram and produces datagram B from datagram A is a transformation. And so transformation technologies, include things that do projections and coalescence. Hadoop, for example, can be used to coalesce data or index data. It can be used to change datagram A to datagram B. And a lot of things do that. ETL engines do that. Streaming tools often do that. And so transformation as a separate pillar, where as a matter of architecture, as we're decomposing our domain-driven model into smaller and smaller pieces, we say, okay, there is a deliberate transformation here, and it may be part of, a bigger implementation, and maybe part of what will end up being a deployable unit, as a library in a deployable unit or whatever, or it could be something that stands on its own. But we want to call out transformation on datagrams in the same way that we call out transportation of datagrams as a top-level pillar. And then the other pillar. Things that just don't fit into them, but we know we need for a solution. Encryption services, monitoring services, build tools, configuration tools, and so on. And these typically don't show up in the domain model, but they do show up in the requirements that are powering the domain model. So there is this bucket that says, let's not forget about these things. They're important,